Secure AI starts with architecture, not after-the-fact controls. In this module, we'll connect identity, data protection, prompt safety, isolation, observability, and response into a practical operating model for building enterprise AI systems that are secure by design. We've already covered enterprise AI adoption, governance accountability, and AI-specific risk modeling. Now we move from evaluation to execution. The architecture, controls, monitoring, and deployment safeguards that allow AI to operate safely at enterprise scale. Traditional applications protect code, users, data, and APIs. AI systems add new trust boundaries: prompts, retrieved context, vector stores, model endpoints, plugins, and agent tools. Each can influence system behavior, and model responses are probabilistic, not guaranteed safe. That means architecture must treat outputs as untrusted, validate actions before execution, monitor runtime behavior, and apply access control across design, build, deployment, and incident response. Enterprise AI security works best as a layered control model, not a single gateway in front of a model. Identity determines who can act. Data and prompt controls reduce leakage and manipulation. API and model controls govern how systems connect. AI infrastructure, including vector databases, embeddings, endpoints, and retrieval pipelines, needs its own protection. Runtime monitoring, logging, isolation, and response. Then catch what prevention misses. The goal is defense in depth. Detect, limit, and contain failures. Zero trust for AI extends. Never trust, always verify across every interaction. A request is not safe just because it comes from an employee, an agent, a model endpoint, or a trusted plugin. It must be authenticated, authorized, inspected, logged, and continuously monitored. The same applies to retrieved data and model outputs. Treat them as untrusted until policy, context, and expected behavior confirm they are appropriate for the user, task, and risk level. Every AI agent should be treated like a machine identity, not a generic application feature. Give each agent, model service, orchestration layer, and workflow its own identity with narrowly scoped permissions. Avoid shared credentials. Use short-lived tokens, workload identity federation, and regular secrets rotation where possible. Then constrain what the agent can read, write, invoke, approve, or execute. As tools and workflows change, permissions need periodic review, especially before agents gain access to new data, APIs, or business actions. Sensitive data can appear in more AI system locations than people expect. Prompts, retrieved documents, embeddings, logs, and generated outputs. The goal is to shrink exposure at every handoff. Send only the context needed, classify sensitive content, and redact or tokenize values before they reach the model when possible. Protect what remains with encryption, access controls, tenant-isolated vector stores, secure backups, and clear deletion procedures. A secure prompt gateway acts as the checkpoint between user requests and model endpoints. Before a prompt reaches the model, it is inspected for injection, jailbreaks, sensitive data, and policy violations. The gateway then selects the right model path based on user role, data classification, and risk. After generation, responses are checked for leakage, unsafe content, and hallucination risk. Privacy-aware logs preserve evidence for audits and incident response. AI workloads should be separated into security zones, not treated as one shared playground. Development, testing, sandbox, and production. AI need distinct identities, datasets, networks, and policies. That separation limits blast radius if an experiment fails or a model is compromised. Any connection to production systems should require review, approval gates, rollback planning, and monitoring. For regulated data, customer records, finance, or operational technology, use stronger isolation such as dedicated accounts, segmented networks, and controlled API paths. Every AI call should be treated as a controlled service invocation, not a free pass into enterprise systems. A gateway becomes the enforcement point between agents, applications, tools, data, and model providers. It checks identity, authorization, rate limits, schemas, filtering, DLP, and audit logging before anything moves forward. Model access should also reflect role, geography, data sensitivity, and approved purpose. For agents, use allow-listed tools only and block arbitrary code execution or unrestricted API calling by design. AI observability captures the signals that explain how the system behaves, not just whether servers are healthy. Log prompt and response metadata, user identity, model choice, retrieval sources, tool calls, policy decisions, and errors. Then use those signals to detect jailbreak attempts, abnormal access, unusual agent actions, and usage spikes. Feed the results into SIEM and SOC workflows while minimizing sensitive content retention, so investigation does not create new privacy risk. When AI recommends a high-impact action, automation should not be the immediate next step. First, classify the risk. Payments, access changes, legal decisions, deployments, and customer messages need stronger control. Then verify the evidence against policy, rules, source records, or another model. If confidence is low or evidence is missing, the system pauses, denies, or escalates. Only approved actions execute, and every approval, reviewer, evidence source, and final action is recorded for auditability. Scalable AI security comes from reusable patterns, not constant reinvention. A secure prompt gateway provides a common control point for inspection, policy, routing, and response checks. Observability makes AI behavior visible to security teams, so incidents can be detected and investigated. Agent identity treats bots and workflows as accountable actors with permissions and lifecycle controls. Human approval gateways keep high-impact decisions from becoming fully autonomous. Together, these patterns turn AI security into repeatable engineering practice. Most AI security failures are not exotic. They come from familiar shortcuts: public access, shared credentials, direct production hooks, missing logs, weak validation, and agents with too much authority. The safer pattern is straightforward. Treat AI as semi-untrusted, give each workload its own governed identity, verify outputs before action, and collect telemetry continuously. If you cannot monitor it or explain its authority, you should not trust it. Secure AI architecture is trust by design: zero trust, least privilege, protected data, governed prompts, isolated workloads, observability, and human verification. These patterns help teams scale controls and spot anti-patterns early. Next, we apply them to LLMs, RAG pipelines, agents, APIs, and SOC operations.